Hey guys, welcome back to Chris V's RF. This is going to be an update on my software that I've designed, and in order for me to find a way in order to design low noise amplifiers, and so that I don't have to rely on Advanced Design System or MATLAB or any of those softwares. But this is the fifth update on this software, where the last video I was designing a low noise amplifier using lump components. This time it's going to be using microstrip transmission line. And so I also created a website here, and you guys can read what I have posted here on there. It's all about how I'm going to post my software on here, and also I'm going to post all of my projects that I do to create all these RF projects, in order so that one day I'm hoping that I'll be able to create my own radio frequency integrated circuit design, which is a goal that I have had for a long time. That's something I've always wanted to do. And if you can't find work or do something, then just, I guess, make it a hobby and try to find a way to design one yourself, hopefully. But so that's how I decided I wanted to go ahead and just program my own software here, and maybe you guys would like to use it too. But anyway, you can basically just sign up, create an account. There is a fee. You just have to, it's a small fee right now, but later on, so you will only have to pay one time. It's only not that much, but you'll see. And basically it's just that you'll get an exclusive grandfather sign up plan. Basically you have it and it's yours until the end. So if you get it for $5, and you'll have that for $5, or $1, and that'll be all yours, all the whole way. So I'll go ahead and start my project now. I'm going to go ahead and actually design a maybe about, let's see here, we can do like a 5 or 6 gigahertz low noise amplifier using microstrip transmission line here. So first, what you want to do is create a termination here, which is, for example, you need to have a 50 ohm termination. It could be, for example, like an antenna. Then you also want to stabilize the transistor that you're going to use. I'm just basically going to be doing a circuit that I have been, I can go ahead and let's do 100, for example. And this time I'm not going to be using ATF55143. I've been using that so many times. This time I decided, I was like, I want to use this SAV 541. You can see what it's good for. It's good between 0.045 to 6 gigahertz. You can see what it's all good for here. It has the S parameters that I'll be using right here. You have to copy and paste them into a S parameter file, and that S parameter file would be like right here. So mine does not take, it's not like the Keystone format that you would do in Advanced Design System or MATLAB. I did it kind of a little differently in my programming. I basically said that the first column is all the frequencies in gigahertz. So no matter what, it's going to be in gigahertz. And because we're also, I mean, gigahertz is, if you convert it to wavelengths and stuff, you'll get lengths that are within centimeters, and you'll see that I'll be entering centimeters and for width and height and everything. Anyway, you need to have all the S parameters, S11 all the way to S22 here. So that would be that. Then you'll just open that file, and there you go. And we could put 100 ohms here to stabilize the transistor. Let's see here. Alright, and we have to pick a frequency, and the frequency is actually the different row inside the file here. So if I want to design something that's going to be at 5 gigahertz, then that will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would be the 10th row. So I'm going to put in 10, but hopefully that'll work. Okay, so you can see that it's going to be unstable because the stability circle is inside the Smith chart. So I actually had this working. I had the source and the load stability circles working, but for some reason the load one is not working, or it's either the source, I forget which one it is, but either way they have to be outside of the Smith chart. So in order to get it outside of the Smith chart, we can decrease the resistance here, but instead, so we could also, what we can do to change the values, we can't change the values in here in the circuit because it won't work. you can't delete it and re-put something in. But later on, I'm not like the best programmer here. I'm really just trying to design a software where hopefully design my own radio frequency integrated circuit designs. So gotta just start from the basics and then work our way up, you know. So anyway, we will go here, change the resistance value. This is the resistance value right here. We would do 40 and 40. I did this before. So actually, instead of this being in like shunt here, this shunt resistance, instead we want to have it in series instead. We can make a series resistor instead of it being a shunt. A shunt means that it's going to ground, but in series you'll see here. So we can save this and then simulate. And there you go. We got the circle outside of the Smith chart. And so we can find a gain. Let's say a gain is like 5 dB. Okay, we can go bigger then. We can go 10. And this is the available gain circle. And the available gain circle, if we get it to the point as small as we can get it to, we can get the highest gain. So I just want to have the highest gain. If it's not like I'm trying to really design this as a low noise amplifier, but just trying to give you the basics of what it would be like to create some amplification for that frequency. So we can try 10 here, 10 dB here. I think we already did that one. 15, 16. And when you see that the circle's gone, it means that it's about at that point right here. But it's nicer to see what the circle is again, because you need it. Let's see here, 16 I think, or 15. Yeah, 15. Okay, so we can do 15.5 and 15.2. Okay, 15.3. Alright, so we get really close. We'll go ahead and do this point here. So we want to, what you're going to be doing is you're going to click inside the circle here of the available gain, and in the center. We could also, if you were to actually really design a low noise amplifier, you could put in the noise figure parameters for the transistor. They even give you the noise figure parameters right here in the data sheet. So just click it. Click in the center. That would be given the highest gain. So I forgot. You have to make sure that you need to click on either the lump component matching or the transmission line matching. Lump components, it's a little different in how you would work it with the chart, but with the transmission line it's a little different. So here you will, as soon as you click it, it's going to come up with a screen showing you all the parameters. What you would want your width of your microstrip to be. I'm going to put it 0.085. I'm going to put here 4.8. It could be like a FR4 board. Depth 0.06. And 3. And we get close to 50, but that should do. We will use that. And so we're working at 5 gigahertz, I guess. Sometimes I've noticed that it will not work at 5. It'll work at the frequency below it for some reason. It might be the programming issue or... Okay. So we got the 56 ohms, and so we're going to keep that 56 ohms. Next, you're going to click on distance. This stub length, you're not going to deal with this stub length thing. I first initially did it because I thought maybe I might have to do something else, but actually the thing is as soon as I find the distance, I'm basically going around the Smith chart. So I'm going to click in the center of the available gain circle. Okay, and that creates the input and output impedances. I believe, or it's the admittances. I forget. Anyway, what you're going to do is you're going to click on here, and it'll create a circle, and that circle there, you'll let go of it because you want to have that circle go to the point circle unit, basically 1, which is 50 ohms. And now let go of the mouse, and you should get the distance of the transmission line right here. So we can write that down. Alright, we can write this down. So what we're going to use, let's see here, dA is equal to 0.914 centimeters. That's what this is right here. And press OK. And then it's distance of the stub. The stub here, you can see it's going to be 6.6. Actually, it'd be 0.667 centimeters. Alright, that will be for the input. Input match. Okay, and then the output match. Okay. So basically, that point goes to the 0 point, so we're going to have to re-click inside the center of the available gain circle again to we put our output, I think it's the admittance, yeah, the admittance point. And then we're going to go from that to, we're going to click on the blue point. That will be the output. And then we're going to go to this circle here. We want to go to this main circle because we want to go to the center of the Smith chart. We want to make sure that it's within the 50 ohm characteristic impedance. So let's see here. DA is 0.608 centimeters. Okay, and then DL is going to be 0.679 centimeters. Alright, so we got everything. We see that our stability, so it's not 100, and we don't have, this is incorrect circuit because we changed it. We changed it to 40 with a series. So we have to, in order to change it to series, it needs to be a 0. And then if it was to be a shunt, then it would be a 1. Okay? But anyway, next thing, we can close out. I'm going to redo a whole new circuit. So 50 ohms. And then we have the stub is 0.667. Width 0.085. You can go back to the beginning of the video if you don't remember that I put that down. 0.06 for the depth. 0.003, 50. By the way, that properties button does not work. I will fix that later on. Here you go. Length 0.914. 914. 5. Okay. 4.8. 0.06. 0.03. 50. And now we had our series 40 ohm resistor. Now bring in our transistor. Our transistor was SAV 541 plus. And hopefully you guys could tell that why I picked SAV 541 for 5 gigahertz, since, you know, its range is between right here to 6 gigahertz. So .608. 0.035. 0.06, 0.003, and 50. MT line. 679. And our 50 ohm output. Characteristic impedance is 50. So now we can check our S parameters, and as you can see, so it's actually now 4 gigahertz here. As I said in the beginning of the video, that for matching, it seems to like have one frequency below it for some reason. Somehow my programming is not, it's kind of off a little bit. But whatever I have, the values I have exactly as I have it here, the S parameter frequency response is correct. So no matter what, this is how the circuit right here would behave. What could be a problem though is just the Smith chart that I have to work on with getting it to work exactly at that point somehow. I've also noticed that if you can also change the you can change all of this stuff. You can change the depth, the thickness, the characteristic impedance. No, you don't want to change the characteristic impedance actually. It's a different one right now. 50 right now. I have to go through the program, make sure that, you know, in order so that you can change the characteristic impedance to like different sizes. But anyway, so you got the length, all this here we can change here, and in order to change it, we, as I said, I would go to compdata.txt, and then you can see here that we have all of our, this is basically the circuit data, and in order to get this from the circuit, how the circuit looks like exactly in paper right here, it shows, you know, like if it's either like series or if it's 50 ohms and everything here. It's not a resistor, it's not an inductor, it's not none of these, so that's why they have a 0 there. Anyway, that's that. You could change it to a different ER, different dielectric. I think it's the permittivity. So I could put 9.6 for aluminum substrate. so a different substrate you could use, and that would change the response of the frequency. Actually, it changes it back down another one less than the frequency that it was at before. It goes down to 3 instead. Anyway, that's that. I'm just wanted to really just get this video out there. There's a lot to do. I have a lot of coding I need to do to really get this program working. I've been trying to create my website for the past week and a half or 2 weeks, and haven't been able to get back to the actual coding and everything, so there's not a lot of change, but I guess a little bit of change there. It's not too much. It's a lot. Anyway, please sign up, and I will show you. I will keep the link in the description below, so for you to go to and sign up if you'd like. And it's literally $1 or $2, but it's going to come up. It's going to go up if you need to make sure that you sign up first, and then you will get that the best offer you can get. So I hope you'll like it, and that'll be great to see that people are very interested with this. I took me almost a year and a half to design the whole software here, and I want to really design my radio frequency integrated circuit design. Hopefully within the next year or two, maybe I'll actually get something going. But in order to see the progress of what I'm doing, go ahead and sign up, and you'll see everything that I've done. And you can learn from it, and hopefully even maybe in the future I'm planning to people can work with me, so that'll be great. Hopefully you like my video, and please subscribe, and you guys have a happy holiday.